Hi everyone, today is a new video about how to solve again. Today's question is about given you have two quadrants, one is a smaller quadrant over here, and the other one is the bigger quadrant. You are given that there's a line that joins from one point of the smaller quadrant all the way to another point of the bigger quadrant, such that the intersection point on the arc of the bigger quadrant is midway between each points. So in other words, this length over here and this length over here, they are equal in length. So you are asked to find what is the angle x. Okay, in other words, what is this angle over here? So the solution of this problem, okay, I'm just basically letting, first of all, the radius, okay, of the smaller quadrant to be small r, and the radius of the bigger quadrant to be capital R. Okay, so now I'm going to draw two parallel lines. These two parallel lines starts from this point over here, all the way it goes and touch this side, okay? As well as another parallel line from the midpoint all the way it goes here. So these two lines, okay, they are established as parallel lines. Now, I'm going to label these points, okay? ABC, okay, ED, okay, FG. All right. So these are the respective points. Now, to know about that, right? Okay, these points, okay, allow us to actually establish, like what we can see over here, a pair of similar triangles. Thus, in this case, triangle, okay, CBE is similar to triangle CAD. Okay, so you can see because of all their angles are the same. So this small triangle and these big triangles, they are similar triangles. Thus, okay, I find a relationship. In this case, it will be BE over AD is the same as the ratio of CB over CA. And in this case, okay, we can see straight away, okay, this length is 1 unit and this length will be 2 units. So it is 1:2. Okay, that's the ratio. And that's what we are given. Now, in this case, okay, by rearranging the equation, I get 2 times of the length BE is equals to AD. Okay, I hope you can see what's going on. So once I got this relationship over here of this equation, okay, what we can see, I can write AD, the length AD, okay, likewise over here, A to the point D as small letter r plus capital letter R. Okay, because you can see that this is the radius of the smaller quadrant, radius of the bigger quadrant. So by summing them up, okay, I get the length AD. Okay, AD is over here, which in this case, it gives us 2 times of BE. Okay, I hope you see what's going on. So by rearranging the terms, I get BE, the length BE, to be capital letter R plus small letter r over 2. Okay, so you can see what's going on here. So now I'm going to establish, okay, what I have gotten. Okay, so if BE is capital letter R plus small letter r over 2, I can also say that this length is capital letter R plus r over 2. Okay, now, since this is a quadrant, okay, this is the big quadrant. So if that's the big quadrant, I can straight away say that this length is capital letter R as well because it's the radius. Okay. So CF is basically capital letter R. Now, if I'm going to draw a diagonal line, okay, from the point F all the way to this midpoint of AC, which is at point B, I also get a capital letter R. Okay, this is also the radius of the big quadrant. Okay, so this length is capital letter R. Okay. Now, so if we can apply the Pythagorean theorem, EF, okay, we can find the length of EF to be the square root, okay, of BF squared minus BE squared. Okay, because what we are actually seeing is we are looking at triangle BEF. Okay, so from triangle BEF is a right triangle. So we by establishing, okay, EF is this length, BF is this capital letter R, okay, the radius of the big quadrant, and BE, okay, the length BE, okay, is what we have established earlier. Okay, what we have found, capital letter R plus small letter r over 2. Okay. So now I'm going to plunge in the respective values for cap R and small r. So in this case, okay, BF, okay, we know that BF is capital letter R minus BE square. Okay, so BE, whole thing, I'm going to bracket them up and square. I got capital letter R plus small letter r square over 2 square, which is 4. Okay, I hope you can see what's over here. So now I'm going to look at another property. Okay, in this case, CE, the length CE. Okay, the length CE, we can see that it is CF, okay, this huge length over here, the radius of the big quadrant, minus EF. Okay, EF is this length. Okay, and that's what we get for CE. So by subtracting them, notice, okay, CF is what we have gotten. Okay, CF, which is the capital letter R, subtract. Okay, so basically I'm just subtracting what we have found here for EF. Okay, so I subtract them. Okay, and I get capital letter R minus the square root of capital letter R square minus capital letter R plus small letter r square over 4. Okay, so that's the length of CE. Okay, this length here. Now, in the next slide, okay, now I'm going to look at triangle CBE. Okay, so triangle CBE, this is CBE. I can tell from, okay, the tangent, okay, the tangent ratio of the angle x. Okay, so now I'm applying a little bit on trigonometry. So the tangent of this angle that we are going to find, tangent of x, is BE over CE. Okay, because B is the opposite side and C is the adjacent side. Okay, so I'm establishing the tangent ratio for the angle x. Thus, okay, like what we have actually found, okay, for the length of BE and CE earlier, okay, in our earlier calculations, okay, from all the equations. Remember, BE is capital letter R plus small letter r over 2 over, which is the ratio, okay, R, which is CE, R minus the square root of capital letter R square minus capital letter R plus small letter r square over 4. Okay, that's what we have found earlier. So, okay, in the next slide, okay, just a minute. Okay. So from triangle CAD, now we are looking at triangle CAD. Okay, this big triangle. So in this big triangle, we can also see that it shares a common angle, the angle X. So we can say that the tangent of the angle X is also equals to AD, the length AD, over CD. Okay, CD is this length, AD is this huge length. Okay, the opposite over the adjacent side. Likewise, if you look carefully, AD is simply our small letter r plus capital letter R, and our CD is simply our capital letter R minus the small letter r, because DF over here is the same as the radius, the small radius, okay, of the small quadrant. So it will be simply capital letter R plus small letter r over capital letter R minus small letter r. Okay, so now, why do we establish these two equations over here, these two ratio? Because we are going to form, okay, an equation by equating this part with this part. Okay, because you can see that it is tangent of x. Okay, they are same angle. We're talking about the same angle. So we can equate the ratio and find the relationship between capital letter R and small letter r. Hence, okay, so by equating them, I get this on the left hand side. Okay, basically this whole equation on the left hand side, and this equation, this ratio on the right hand side. Okay, so that's the equation. Okay, so now I'm going to write this equation over here. Okay, and now I'm going to express capital letter R with respect to small letter r and see what's going on. Now, very quickly, okay, what I'm doing here is I'm taking the numerator from the left-hand side, okay, R plus capital letter R over 2, over to the right-hand side. So if I'm going to bring this over, I can do a reciprocal. I'm basically doing a reciprocal with here, left-hand side, the right-hand side and left-hand side. And, okay, and I get capital letter R minus small letter r over capital letter R plus small letter r. okay, multiply by capital letter R plus small letter r over 2. Okay, so that's what I got now on the right hand side. Okay, simply by doing a reciprocal on the right and the left, okay, and bring capital letter R plus small letter r over 2 to the right hand side. Okay, I hope you can see what's going on. And the left hand side now, left is the denominator over here. Okay, so now further rearranging, okay, I bring capital letter R and the minus sign over to the right. Okay, now I get very simple. Oh, before that, right, I also can see that the capital letter R plus small letter r can be cancelled off in this case. And I'm left with capital letter R minus small letter r over 2. Okay, since I'm going to bring capital letter R over, in this case, it will be a negative sign over here of capital letter R minus small letter r over 2 plus capital letter R. Okay, this capital letter R is this one on the left hand side. Okay, and now I'm left with the third. Okay, basically the root, okay, the third that is over here. Okay, which I just write it down. So the next step, okay, what am I doing? Basically, okay, now I'm going to open up the equation. I'm going to open up by expanding out all the binomials over here. Small letter r plus capital letter R square. Okay, I'm going to open this up. Okay, likewise, I'm going to combine the fractions inside the third. And by squaring both sides of the equation. Okay, I know I'm taking a little bit steps ahead. However, okay, for those of you who can see that, okay, yeah, this is basically what's the next step. So basically you have, in this case, capital letter R square plus 2 times of capital letter R times the small letter r plus small letter r square. Okay, over here. And by combining the fraction, you have 4 capital letter R square over here, minus off this whole binomial over the denominator, which is 4. Squaring the third takes away the square root sign. And over here, basically what I did, because I have to now square the right-hand side. So by squaring the right-hand side, I get this term here, square, okay, as well as 2 times r, capital letter R minus small letter r over 2 and capital letter R. Okay, in this case, 2 times of 2, over here, I just remove it. It becomes 1. So what you're left with basically is minus capital letter R of capital letter R minus small letter r plus capital letter R square. Okay, basically this is just an expansion over here by squaring it. Okay, so the next step, very quickly, okay, I combine the like terms together. Okay, 4r squared minus r squared, I get 3r capital letter R squared, minus 2 times of capital letter R of small letter r, okay, and minus small letter r squared over 4. Okay, so that's the left-hand side. And on the right-hand side, okay, very simple. I just open up this, okay, this binomial over here. I expand it out. I get, okay, capital letter R squared minus 2 times of capital letter R of small letter r plus small letter r squared over 4. Okay, so that's what we get for this part. Now, as for this part over here, okay, basically I expand out, okay, capital letter R of capital letter R with small letter r, okay, I get minus capital letter R squared plus small letter r, capital letter R. Oh, sorry, plus, because minus and minus sign, yeah, so it becomes plus. Okay, and capital letter R squared will be deducted, okay, it will be subtracted. So now the equation at this point has been reduced, okay, to a simpler form. However, that's not all. Okay, so the next step, what am I going to establish is I'm going to combine the fraction on the right-hand side. So by combining the fraction on the right-hand side, okay, notice, okay, so I'm going to bring up the denominator, which is 4. So 4 times of capital letter R, small letter r, okay, plus minus 2 of capital letter R and small letter r, I get 2 times of capital letter R and small letter r. Whereas the other terms remain the same. And now the fraction has grouped themselves together. So why is this interesting is because I want to get rid of the 4. How do I get rid of it? Basically, I just have to multiply by 4 on both sides. And by doing so, I end up with this following quadratic equation. So this quadratic equation, it says here, huh? okay, if I'm going to simplify the terms, I just bring the terms over and I go to subtract them, add them. I will end up with capital letter R square minus 2 times of capital letter R of small letter r minus small letter r square equals to 0. So for those of you who can do a quick calculation, this is what I gotten, okay, as the quadratic relationship between the capital letter R and small letter r. Namely, okay, the radius of the big quadrant and the radius of the small quadrant. So I'm going to apply the quadratic formula. So in this case, okay, the next step. Okay, so I apply the quadratic formula. I will get, okay, in this case, what am I doing is basically I'm using capital letter R as, okay, as the, what do you call that, the variable. And I just take out the small letter r. So in this case, I get 2 times because minus of the b term, which is minus 2 times of small letter r. And I get 2 times of small letter r plus minus the root of, basically we call it the b term square minus 4 times of the a term and the c term. So if you do some calculation, you are able to see where is this going. Okay, over 2 times of the first term. The first term in this case is 1. 2 times of 1 is 2. Okay. So subsequently, okay, by simplifying the third over here, okay, in the quadratic formula, I get the root of 8 times of small letter r, and over here, 2 times of small letter r plus minus over 2. So furthermore, okay, I just simplify out the root of 8. Okay, so the root of 8 is basically 2 times the root of 2. So by factorizing, okay, the terms, I get 2 times of small letter r plus minus the root of 2 of small letter r over 2. Hence, the next step, very straightforward. Capital letter R, the relationship with small letter r is basically the ratio, okay, of big R to small r is 1 plus minus the square root of 2. So in this case, okay, since we are dealing with geometry, we have to take the plus value because the minus value will give us a negative number. So in this case, we take the plus number, which is 1 plus square root of 2, okay, of small letter r. Okay, so going back, so now we have this established, okay, cap r and small r. Now I'm going back to the tangent ratio, AD over CD. Remember earlier? Now, AD over CD, we got it as capital letter R plus small letter r over capital letter R minus small letter r. So as a result, since we have the relationship over here, okay, we have this relation over here. Now, what am I going to do? Basically, if I'm going to find cap R plus small r, I get R times of 2 plus root of 2 because I just add in, okay, another small r inside. So if I add in one more r inside, I get 2 times of r, small r, okay, of square root of 2. So in this case, it will be 2 plus root 2 of r. Okay, I hope you are seeing what's going on here. Likewise, cap r minus small r. Okay, if I'm going to minus off 1 unit of small letter r from here, small letter r will be gone. So you're only left with the square root of 2 of small letter r. Okay, thus, the value of cap r plus small r over cap r minus small r will be equals to, over here, okay, 2 plus root 2 of r over root 2 of r. So in this case, the r, small r, and small r can be cancelled off in the ratio. And thus, we get the ratio of tangent of x to be equals to, in this case, if I simplify this term, to be the square root of 2 plus 1, and that's it. Okay, so because how do we get this? Very simple. Okay, we just split the fraction again. Okay, 2 over root of 2 is basically root of 2. Root of 2 over root of 2 is 1. Okay, which is equals to tangent of x. Okay, because we found the ratio and then we just plunge in the value for tangent of x. Now, very simple, tangent of x is root 2 plus 1. Thus, the value of x, if by calculation, you will get exactly at 67.5 degrees. And that is the answer to the problem. Okay, so the value of x is 67.5 degrees. Have you got it? Okay. Now, okay, thank you very much for watching and hope to do another math video in the not too distant future. So stay tuned and thank you very much. Goodbye.